Hiya, so this is January 2020, paper 1H, okay? What I'm going to do is go through the whole paper, alright? And it's up to you to have your paper out ready. If you haven't got it, pause the video, go get it, okay? And I'm going to go over the questions, okay? What I'm going to do is I'm going to go over the questions the way I think it should be done. In other words, the quickest possible, most straightforward, most logical way. If you've got the same answer but a slightly different way, just check it, okay? And ask me if you're not too sure, alright? But if you haven't done it my method, then maybe just have a think about that, okay? Every time you need to make a note, just pause the video and just make a note on it, okay? If you're going along, try and award yourself marks to give you an idea of how far you got, okay? Try and use your own judgment and use the mark scheme as well, okay? But one of the reasons I'm doing this is because sometimes mark schemes are not great, are they? So question 1. Alright, by the way, I'm going through all of these in order, so if you want to wait until your question, just skim through the video or just watch to see how I do it anyway. Okay. So question 1, work out the midpoints of coordinates. Okay. So remind of midpoints. Okay. So when you've got a pair of coordinates, x1, y1 and x2, y2, what you do is you add the x coordinates together and divide by 2, and you add the y coordinates together and divide by 2. Okay, really important. Find the midpoint is the same as find the median from two sets of numbers. Okay, so find the median, you add the numbers together and divide by 2, don't you? Okay, so final question, 5 plus 13 divided by 2 is 9, and negative 4 plus 1 divided by 2 is negative 1.5. So that's your answer for part A. All right, part B. Write down the gradient, should be simple enough, negative 3. And part C, does the point with coordinates 100, negative 302 lie on L? Obviously, you've got to give an answer, as in yes or no, and you've got to give a reason as well. Okay. The best thing to do is to substitute in the x coordinate and see what happens. Okay. So you've got x is 100. Use the equation to work out what the y coordinate should be. All right. So y coordinate should be 2, subtract 3 times 100. So it should be 2, subtract 300. The y coordinate should be negative 298, but it's not, is it? It's negative 302. So you write, therefore, no, since y is not equal to negative 302, or something similar. Okay, but that's the best way of doing it, substituting in to work out what the actual coordinates should be. Okay, right, moving on, question number 2. Lowest common multiple. Now I'm going to show you how to do this using a Venn diagram. Some of you don't use Venn diagrams, which is fair enough, but when the numbers are really difficult, or when there's algebra involved, they're difficult ones, aren't they? When there's algebra involved, Venn diagrams are the way to go, really, okay? So question 2, you could use a factor tree, okay? I suggest you use a factor tree to work out the factors of 28, so it should be 2 times 2 times 7, and 105 is 3 times 5 times 7. So I'm not drawing a factor tree, but that's what you should have got. Okay. Now, how does a Venn diagram work? Okay. So we've got 2 overlapping loops. Okay. One loop is to represent 28. The other loop is to represent 105. Okay. The common factor between two of them goes in the middle, the overlap. Okay. So from these, can you see the common factor is going to be 7 because it's common to both. Okay. So for 28, you've got 2 times 2 times 7. The 2 and the 2 go there. You see, 2 times 2 times 7 is 28. And for 105, the 3 and the 5 go there. So 7 times 3 times 5 is 105. That's how a Venn diagram effectively works for this. Okay, and yeah, to be accurate, should have the rectangle as well. But you don't have to in this question, to be honest. Okay, right. The lowest common multiple is going to be that times that times that times that times that. Always works. Always works. Okay, as long as you've done these numbers correctly, then the lowest common multiple is always when you multiply all these together. Okay, so you're going to have 2 times 2 times 7 times 3 times by 5. Okay, and then that's it, and you should get 420. You may have used a different method, but as I said, this is the method I would advocate for the more difficult questions. Okay, so I'll show that to you on the board there. Right, question number 3. Okay, diagram shows a shape, fairly easy shape, isn't it? 2 rectangles. Could it be any easier? Not really. Okay. There you go. So it shows a shape. So you've got the large rectangle here. Obviously it's got an area of 108 centimetres squared. Okay, got the 12 times by 9. And then that means this one here in the end, that must be 21 centimetres squared, because you're told the total area is 129, aren't you? Okay, so if that's 21, you've got to work out that is, this bit there is 9, this bit there you're told is 6, so 9, 6, that bit there must be 3, x must be 7. Okay, 4 marks. 4. It's very generous, wasn't it, that question? If only all questions were that easy, but they're not. Moving on, question number 4. Okay, so write down the modal class. That's the one that occurs most often. So you need to write down exactly as it says in the table. So 3 less than w less than or equal to 4. Okay, part B, work out an estimate for the mean. Now what you need to do is work out the midpoints, okay, for these weight values. So the midpoints, I'm going to call them x. Okay, so that's going to be 2.5, 3.5, 4.5, 5.5, 6.5. How easy was that? Very easy, though. Okay. And what you can do is you can multiply those by the frequency. So I'm going to write that as fx, f times x, frequency times by the mid values. Okay. So 12 times 2.5 is 30, and then 3.5 times 16 is 56. 4.5 times 9 is 40. 5.5 times 2 is 11. 6.5 times 1 is 6.5. You add all those together, and you should get 144. Okay, and then what you do is you divide 144 by 40, because it says there are 40 babies altogether, and that gives you an answer of 3.6. Do not round it. A mean, okay, is not to be rounded unless you're told to. Okay, so that is your mean average, 3.6. It doesn't matter that you can't have 3.6 babies. It is an average figure. Okay. Part C, find the probability that the weight is more than 5 kilograms. So what you do is you look at the table and you look at the frequency that is above 5 kilograms. So that's the last two groups, isn't it? 5 to 6 and 6 to 7. Okay. So that's 2 plus 1, that's 3 altogether. So there's 3 altogether that weigh more than 5 kilograms, and it's out of 40 babies. That's it. 3 out of 40. 3/40, right, as a fraction. Okay. Remember, fractions are best, as opposed to decimals. Okay. Never ever use percentages for probability. If you've written a percentage for probability, cross it out now. Okay. I mean now. Don't wait, now. I don't like to see percentages. Why not? Because you cannot multiply percentages together. Okay, there's a tree diagrams question coming up later, isn't there? We have to multiply probabilities together. You can't multiply percentages together. It doesn't work that way. So fractions or decimals, but fractions are better. Okay. Did you cross out a percentage? You better have done. Okay. Right. Question number 5. I hate these questions. They're so fiddly. I really hate them. Yeah. It's like yeah. Yeah. I don't like questions where there's a load of reading to do and it's like, oh, ratio this, fraction this, percentage this. Anyway, so that's my moan out of the way. Okay. So 120 children, girls to boys, is a ratio of 3 to 5. Okay. So 120 divided by 8 gives you 15, because it's 8 parts altogether, ratio 3 to 5, that's how ratios work. So that means 3 for girls, 5 for boys, so 3 times 15 is 45 girls, and 15 times 5, 75 boys. So that's the first thing you should have worked out, 45 girls, 75 boys. Check that they add up to 120, 120 children as well. Okay. Right, next, 16/25 of the boys go climbing. Okay. I mean, who says these things? Seriously, who says 16/25 of our boys went climbing? Anyway, yeah, so 16/25 of the 75 boys. So, did you use a calculator? Did you? 75 over 25 is 3. 3 times 16 is 48. Okay, so 48 boys went climbing. Okay, and what else does it say? Twice as many girls go sailing as go climbing. So this is how many girls there are. I mean, you could probably do that in your head, can't you? You know, 15 and 30. Yeah, because 30 is twice as much as 15, so it's kind of easy, really, isn't it? So what order is it? So twice as many girls go sailing as climbing. So that means you've got 15 girls climbing, and you've got 30 girls sailing. What's the question after? How many children go sailing? So that's 30 girls sailing, 48 boys are climbing, 75 boys altogether. So 27 boys go sailing, and so just add those together, yeah? So 30 plus 27 equals 57. That's it. 6 marks. Okay, there you go, 6 marks. It's quite a lot there. Right, I'll pause there, take a break, and I'll do the next set of questions in the next video. Okay, next. Question 6, I've just written the answers up because it's that simple, okay? So, write as an ordinary number, so it should be 0.00078, hopefully you've got that, okay? And part B, put it all into your calculator, okay? And then convert it to standard form. You should have 2.25 times 10 to the 7, okay? So obviously that number is 225, and you've got 7 digits after the 2, so 1, 2, 3, 4, 5, 6, 7. Put the commas in because I'm from the UK. So that's 22,500,000. Okay, that's what your calculator may have told you, but that's what you should have there. Okay, that's question 6. Right. Question 7. Expand the brackets. Okay, so maybe some of you can just write down the answer. I'm hoping so. So we've got m squared plus 5m minus 8m subtract 40. Are you using FOIL to expand the brackets? Are you using FOIL? Are you doing it in your head? Okay. Well, whether you are or whether you're not, you've got to do these extremely quickly, okay, almost without thinking really. It's like walking, you should be able to just like, oh yeah, that's simple, okay, because there's a lot of that stuff coming up in year 12, right. Factorized fully. Now be careful of the word fully. Fully means if you've only got one thing outside the brackets, you've not done it, okay, just watch out for that. Fully means there's more than one term outside the brackets. So 5 is an obvious one, isn't it? Okay, because 5 and 20 are divisible by 5, and the other obvious one should be y. So you need to have 5y outside the brackets, okay? And then inside the brackets you've got 1 and then plus 4y, okay? There's a lot of that going on at A level as well. Basically, anything algebra based, be brilliant at it, okay? Because then you're going to hit the ground running for A level maths in September, okay? Which we're all looking forward to, I hope, yeah. Part C. So here we've got p squared plus 3 to the power of 0, so the answer is 1, okay. Yeah, anything to the power of 0 is 1 except 0 itself. What is 0 to the power of 0? I'm not answering that for you. Well, that's just a question for thought, okay. Question D, solve this. So I imagine you've expanded the brackets on the left hand side first to get 6x minus 15 is equal to 9 minus x over 2. Things like this, it's a good idea to show which stage you're working. If you skip bits out and get something wrong, you know, you could get no marks, because if you get the first bit wrong, then everything else is wrong, isn't it? So it's probably a good idea just to take your time. I mean, in an exam, you've got 2 hours. You know, you will be, you know, finishing really early. So, you know, take your time over these questions, okay? So 6x subtract 15 times everything by 2, so 12x minus 30 equals 9 minus x. Put that x into that side, 13x. Put the 30 into that side, equals 39. How nice is that? Yeah, I mean, it's an integer, so x equals 3. Okay, that's it. Done. So, hope that was good for you. Right, question number 8. I'm not going to draw this on the board. Okay, I'm going to show you the answer. Okay, so here it is. Let's just check you can see it nicely. Yes, you can. Okay, you can. So, a good idea to, from the centre of enlargement there, 1, 2, you draw these lines connecting this point here, and this point here, and this point there. And because it's scale factor of a half, you want to go halfway along. Okay, so halfway from there to there ends up there. You can see the 4 crosses are marked there. You ought to have coordinates 6, 3, 8, 3, 8, 6, and 4, 6. Okay, and then you get your marks. Hope that's good for you. Right, question number 9. And we get on to trigonometry. Okay. We love a bit of trigonometry, don't we? Who does not love trigonometry? I'll tell you who does not love trigonometry. People who don't like maths. Okay. If you're one of those who does not like trigonometry, please learn to like it if you want to do it next year. Okay. So what we've got here is we've got a right angled triangle, pretty easy. Okay. So we've got 63-degree angle. Adjacent to that is 24.3, and we want to work out PQ, which is the hypotenuse. Okay. So did you use SOHCAHTOA? Okay. Yeah, SOHCAHTOA, not SOHCAHTOA, SOHCAHTOA, it's like Leviosa. Yeah, okay, so sine opposite hypotenuse, no. Cosine adjacent hypotenuse, sounds right. Tan opposite adjacent, no. So this one there, isn't it, okay? So cosine of 63 degrees is equal to adjacent, 24.3, divided by hypotenuse. I'm going to write it as PQ. You can call it X if you want, or H for hypotenuse, or C, okay, if you want. Now the thing to do is just swap those two over. Okay, notice the PQ, what we want is on the denominator. Swap these two over. So write it as PQ equals 24.3 over cos 63 degrees. Okay, simple. Why does that work? Because what you're doing is you're multiplying by PQ. To get PQ times that equals 24.3, and then you're dividing by cos 63, so it ends up over there. Okay, and that divided by that gives you 53.5 degrees. Okay, well, that's simple, isn't it? Okay, that'll be simple for you. Right, question number 10. Okay, right, shaded region. What they've done for this question is they've given you one of the equations, which is nice of them. You've got to work out what the other two equations actually are. Okay, should be pretty easy really. Okay, so the first equation is y equals a third x minus 2. The vertical line is x equals negative 1. Okay, because it's vertical, it passes through the x coordinate where x is negative 1. And then the other line, the diagonal line with the negative gradient. Okay, are you able to write this down? X plus y equals 4. Okay, here's a hint for you. Okay, when you've got a pair of axes like this, and then you've got a sloping line like this, if they pass through the same intercept on the y and the x-axis, okay, rather simple. The equation is this. Okay, so whatever number that and that are, as long as they're the same, that's the equation. Why does that work? Because if you work it out, the gradient is always negative 1. Okay, so that means your line is y equals negative x plus something, isn't it? The y-intercept is 6. So you can see y equals negative x plus 6 can be rearranged like that. Okay, so it's a rather simple technique for you to try and remember with that question. Okay, so we've got x plus y equals 4, x equals negative 1, and the equation that they gave to us. Okay, now everything is shaded to the right of x equals negative 1. So to the right means x is greater than or equal to negative 1. There's no dashed lines, so you should be using greater than or equal to. Okay. And from the one they give us, y equals 1/3 x minus 2. Everything's shaded above that line, so y is greater than or equal to. That's what you're doing, okay? The y coordinate is effectively your vertical value, okay? How the vertical units are changing, okay? So if you're shading above that line, it's y is greater than or equal to. I hope that made sense, okay? And then the last line, I wrote it two ways, didn't I? Okay, x plus y, 4, okay. What symbol goes in there? The shading is everything below the line, so it's x plus y is less than or equal to 4. Okay, if you wrote it like this, then it's y is less than or equal to negative x plus 4. Okay, right, I'm going to pause again. Alright, question 11. Right, Max, good old Max. Max invests $6,000 in a savings account for 3 years. The account pays compound interest 1.5% per year for the first 2 years. So let's work out how much he's got after that. So $6,000 multiplied by, now 1.5%, that would be a multiplying factor of 1.015, won't it, for the 1 year. For 2 years, it's squared. And we work out what that is. That gives us 6,181.35. Okay, so that's how many dollars he's got at the end of 2 years. Right? The compound interest changes for the third year. At the end of 3 years, there's a total of 6,311.16 in the account. Work out the compound interest. Well, can you see when we had the interest figure, we did a multiplication to get our answer. So when we've got the answer and the initial figure, we just do a division to work out what that compound interest is. Okay. So here's the answer. So you've got 6,311.16. So if we then divide that by 6,181.35, that will give us our multiplying factor, you see. Okay. So we do that division and we get 1.0210 something. Okay. And that tells us then what the compound interest rate was for that year. So remember, 1.015 was 1.5%, 1.021, that's 2.1%. Okay, so 2.1%. Hope that made it clear for you. Yeah. Oh, good for Max. That increased. So that was a bit of a bonus for him, wasn't it? Right, question number 12. Okay. This is a cumulative frequency graph. So what you need to do is draw the lines on your graph as you're working out the answers to this question. So part A, find the interquartile range. So can you see this? I really hope so. Okay, I'll try to make the lines nice and clear for you. So interquartile range, upper quartile 60, read off I got 56, lower quartile 20, read off I got 38. So write those down, okay, and show you working on the cumulative frequency graph. Okay, so you do 56 subtract 38. Okay, and we're going to get the answer of 18. Part B, 60% of the men took 50 minutes or less for the race. No women took 50 minutes or less for the race. Okay, so what you want to do is do a read off from the graph again of 50 minutes. So let me show you again. That's my graph. This is my read off. So 50 minutes up to the graph and across gives you 42. Okay, and all of those are men. Okay, so you've got 42 and all of those are men. Okay, and what it does say is that it represents 60% of all the men. Okay, 60% of men. So what you want to do is work out how much 100% would be. Okay, so find 10% and then find 100% if you want. What I would do is I'll just divide by 0.6. Isn't that nice? 42 divided by 0.6. Because 42 divided by 6 is 7, of course, and therefore your answer is 70 men in total. So that's that question there. All right. Question number 13. How did you feel about this question? Now, it's a bit of an awkward one, really, isn't it? Right. So number 13. So you're given a formula. Pressure is force over area. Okay. A bit of a scientific equation, that one. It says the pressure is 0.14, do not worry about the units, and it says the force is 56, and the only thing we're not told is the area. So even if you don't know what to do with this question, you could substitute those in because it tells us what they are, and there's only one unknown, so you can work out the area, can't you? Remember the earlier question where I said you can just swap those over? Okay, we'll do the same again. You get area equals 56 divided by 0.14. Another nice number, because 56 divided by 14, that is 4. So divided by 0.14, it gives 400. Okay. So the area is 400. Okay. Now the thing is with this, okay, when you've got a cube, I don't have a cube with me, okay, but when you've got a cube, that is a awful cube. Yeah. I'll say it for a third time. When you've got a cube, okay, and it's resting on a surface, it's only that bit which is in contact with the surface, and it's only the base. Okay, so in terms of this equation here, it's only the area of the base that you're interested in. Okay, so this figure 400 there, that represents the area of that base, you see, and it says in the diagram that's the length and width of the cube is W. Okay, so you can work out W is easily because W squared is 400. Again, look how nice that works out, because W turns out to be precisely 20. The question is find the volume of that cube. So W times W times W, W. Yeah, equals 20 cubed. Well, 20 squared is obviously that. 400 times by 20 gives you 8,000. Okay, that's that question. Done. Right, number 14. More trigonometry. Okay. Remember what I said earlier about trigonometry? You've got to love it. Okay, you've got to love trigonometry. Okay. Right, number 14. So, very common scenario. This very common scenario. Okay. So you've got an angle there, 160 degrees. You've got a length here, 9.3, 14.7. Work out the area. What you're always doing is dividing this quadrilateral into two. I say quadrilateral because sometimes you get a kite, sometimes a rhombus, sometimes it's just a quadrilateral, okay? Yeah, but that's what you do, just divide it into two. And use the sine rule. Not the sine rule, I mean the half AB sine C formula. You know the one I mean. Okay, so that's the one you should be using, half AB sine C, where the angle is in the middle of the two sides that you're using. Okay, so you do a half multiplied by 14.7 times by 9.3 times by sine 106 degrees. Now that just gives you one of these triangles. Yeah. To work out the area of the whole thing, you double it. Of course, when you double it, you can do 2 times that, and 2 times a half is just 1. So you just end up having just that. All right, makes sense to you? Good. And then you get 131.414 dot dot dot. Any of you seen Mamma Mia? Whenever I say dot dot dot, I'm thinking of that song. You know the one I mean at the beginning, it's like dot dot dot. You know, it's like yeah, and then they break out into singing. Yeah. Anyway, so yeah, 131.414 dot dot dot. Yeah. 131 to 3 significant figures. All right, that's quite nice and simple, wasn't it? Part B, work out the length of the diagonal, e.g., so that's the diagonal there, and this is when you use the cosine rule. It's quite an easy question, but you should have found this easy. Okay, use the cosine rule. So the way the cosine rule works is you need to locate the angle you're using, and then look at the two sides that are adjacent to that, next to it, and the one that's opposite it, this one, and that's where you start it. You've got EG squared equals, and then this squared plus this squared. I'm not going to repeat the cosine rule formula, look up on the formula sheet. Okay, so you've got 9.3 squared plus 14.7 squared, subtract 2 times 9.3 times 14.7, cosine 106 degrees. I can just about squeeze it on, which is great. Let me just show you some intermediate stages of working. So that squared plus that squared is 302.58, and then this is 75.36 dot dot dot, and then that subtract that is equal. Oh, hang on, no, that was negative. Subtract that. Got carried away in my dot, and that means you just add them together, and then yeah, those you get 377.944 dot dot dot, and then you have to square root, because that's squared, you see, and you just square root that, and then you get 19.440 dot dot dot, and then that's equal to 19.4 to 3 significant figures. Okay, done. How's that for you? Good, I hope. Okay. I'm going to pause it for the next one because that's probably been a long while now. Right, question 15. So you know how to work out the volume of the cuboid. So length times width times height. So that times that times that. Notice the order, because we have to expand these brackets, okay? Do the difficult ones first, yeah? Always expand the hardest brackets first, and then you should find it easier for the last expansion. So I'll put the easiest factor on the end, okay? So we expand these brackets first, so you get this times this, so that's going to be 6x, yeah? And then this times this, subtract 2x squared plus 15, and then subtract 5x, and then in brackets that is x plus 1. Make sure you simplify that first before you do the expansion again, okay? So let's see, that's going to be 15 plus x minus 2x squared. Can you see what I've done there? I've just written it in a logical order, okay, with increasing powers of x. Okay? And then what I do is I do all of those 3 times that, and then all of those 3 times that. You might do it differently, but that's how I do it. So all of those times x gives me 15x plus x squared minus 2x cubed. And then all of those times 1 gives me 15 plus x minus 2x squared. And then I just I'd hint to you, okay, that you should use the answer to help you out, okay? Just check you're getting these, okay? So 15 is what I want. Yeah, I've got 15. And you want to write it in the same order they've written it as well, okay? And then 16x, so that plus that, yeah. So plus 16x. And then minus x squared, so that, subtract that, yep, minus x squared. And then minus 2x cubed, that, yep, good. Okay. Please don't do the crossing out thing. Don't do it just looks horrible and messy. Okay. So that's that question. Okay. Part B. Ooh, calculus. Great. The good stuff. Okay, the good stuff. If you just thought it was calculus, okay. There's a key word there that says maximum. Okay, whenever it says maximum, okay, remember you could plot these on a graph. So look, this equation V equals that. You could plot this on the graph. Okay. What does that look like on the graph? Yeah. I'll show you. Okay. Oh, maybe you pause the video and work it out, and then unpause it. Okay. So here we go. You better have paused it. Maybe some of you did. Okay. Right. Use that for the x-axis crossing points. So that one there is negative 5 over 2. So it's negative 2.5. So put it there. Negative 2.5. That there is 3. So let's put it over there. 3. That there is negative 1. So put it negative 1. Y-intercept. Use that one. 15. Okay, so you can see, and then just join them up, okay, and it just goes something like this. Whee! Like that. That's lovely. Okay, so what they're saying is, okay, there's a maximum point there, ta-da, and there's a minimum point there. Okay, well, I'll just put this down by there for the moment. Okay, and the question is saying, find the value of x, the x coordinates, which the volume V is a maximum. Okay, so that's putting it into context for you. That's why we're going to use calculus. That's why we're going to differentiate, because we want to see when the gradient of this curve is 0. Okay, so we'll differentiate this. How many of you wrote dy dx? Be honest. Be honest. How many wrote dy dx? That's fine. Okay. In A level, no, you will not get away with it. Do not write dy dx. Okay. You've got V equals, so it's dv dx. Okay. Do you remember what dy dx stands for? Dy dx means the rate of change of y with respect to x. When it's y and x, that's fine. Okay, but if I now change that axis to the v axis instead, to match this, it's not dy dx anymore, is it? It's change in v over change in x. Okay, so this is rate of change of volume over x. Okay, so dv dx. Okay, don't worry, you're not going to lose a mark at GCSE level, but you will at A level. Okay, so you use the right letters. So that will be 16, that will be subtract 2x, and that will be subtract 6x squared. There I did it as quickly as I would do in the Year 12 lesson. Okay, hopefully you followed that. All right. And as I said, you've got to set that equal to 0. Now what I do is I multiply throughout by negative 1, because I really don't like the x squared term to be negative. Okay, so I'm going to write 6x squared plus 2x minus 16 equals 0. I can see I can divide everything by 2. So 3x squared plus x minus 8 equals 0. Okay, and I'm going to just quickly check to see if I can factorise that. How am I going to check to see if I can factorise that? I'll use the discriminant, b squared minus 4ac, and the discriminant is, so 1 plus, that's 24 times by 4, that's 48, 96. 97, that's not a square number, therefore it won't factorise. Okay, simple. Okay. So what I'm going to do is I'm going to use the quadratic formula for it. Okay, so the quadratic formula equals this, x is negative 1 to negative b plus minus, and I just wrote down the discriminant, and I b squared minus 4ac, so that was 97, all over 2a, all over 6. Okay, that's your exact answer. Okay, however you only want one of them, but I'm going to work out both of them anyway. Okay, so the negative answer is negative 1.808 dot dot dot, and the other one is 1.474 dot dot dot, and so on. Okay, why do you get two answers? Back to the graph again. Look, see, that's the positive answer, that's 1.474, and that answer there is the negative answer, negative 1.808. So that point would be a minimum if you can have negative values of x, but you can't. Of course you can't. Okay, so it's to be ignored. Okay, so this is the answer we want. What's the degree of accuracy? We're going to leave it to 3 significant figures. So therefore 1.47. Here's our answer. Okay. I hope you enjoyed that. Okay, question 16. So this is upper bounds and lower bounds. So you're given an equation, you just substitute in the values of A, C and D. Okay. So you need to find the upper bound of the final answer. Okay. So what you do is you do 2 times the upper bound for A, and then you subtract the lower bound, because remember you want to subtract as low a number as possible to keep your answer as high as possible. And then you want to divide by the lower bound of D, because you want to divide by the smallest possible number. Okay, so you've got to have the upper bound of A, lower bound of C, lower bound of D. So upper bound of A is 58.45, lower bound of C is 19.5, and then lower bound of D is 3.55. So just put that into your calculator and you should get 27.44 to 2 decimal places. Okay, and that's question 16. Onwards then, question number 17. Yay, surds. Okay. How are you with surds? Now, it comes up quite early on in year 12. Okay, because you need to be able to simplify these things. Show that. We like a good show that question, don't we? Because the answer's there. You can check it. It's kind of nice. So you've got 6 plus 2 root 12 squared. Okay. Show that that is equal to, let's just put the answer at the bottom there. 12, 7 plus 4 root 3. Okay. So it's a good idea to know what you're aiming towards. All right. So question and answer. Now, the 4 root 3. Okay. What I suggest you do is you rewrite the root 12. Okay. So if you want, you can put the working on the side. So you've got root 12, okay, is equal to root 4, root 3, which is equal to 2 root 3. All right. So what it means is that 2 times root 12 is 2 times that. So this is the same as 6 plus 2 times that, 4 root 3 squared. The reason I say that is because then you've got the root 3 in place, you see. It should then just be a case of expand the brackets, taking a factor 12 out, and you've got your answer. Might make things a bit easier. So let's expand the brackets. So that is of course the same as 6 plus 4 root 3. You don't really need this stage, but I would recommend it to make sure you don't make any mistakes. Okay. And then we just do it. 6 times 6 is 36. And then you've got that times that, which is 24 root 3. And of course that times that again, which is another 24 root 3. And then that times that, which is going to be 4 times 4, 16. Root 3 times root 3, 3. 16 times 3, 48. Okay. And simplify it a bit more. 36 plus, and that is 48 root 3 plus 48. Okay. And 36 plus 48, that is 84. Okay, so 84 plus 48 root 3, and it's the same as that. Okay, take a factor 12 out, and you've got 12 times 7 and 12 times 4, so that's it. Okay, you might run it slightly differently, but if you did it much longer than that, take note of the method I've used there. All right. Next, part B. I've used the whole of the board again for this one. All right. So here we go. B, so 27a to the 12 over t to the 15. It's quite a small print, isn't it? To the power of negative 2/3. Right? Break it up. If I were you, I'd deal with the negative power first. Remember, negative power means take the reciprocal. So if you do the negative power, the reciprocal of that will be t to the 15 over 27a to the 12. Okay, and then that is still to the power of 2/3. So you can see I've dealt with the negative just by taking the reciprocal. That's the first step. Okay, you might just get a mark for that. Okay. Then what you could do is apply this rule. So do you remember this rule? So you got, let's write down here, a to the power of m all to the power of n is a to the power of mn. Multiply the indices together. So the algebraic terms, that's what you do. Okay. So t to the 15 to the power of 2/3. You multiply the indices. 15 times 2/3. So 2/3 15 is 10. All right. So t to the 10 over. Let's worry about the 27 in a minute. So a to the 12, same again, multiply indices, 12 times 2/3, 2/3 of 12 is 8. So 8, a to the 8th there, okay. With the numbers, you just got to do it to the power of 2/3. And use your calculator if you need to. 27 to the power of 2/3. It will do it for you. Okay. What I hope you do is realise that the 3 in the denominator means you do the cube root of 27, and the 2 in the 2 in the numerator means you square it. Okay. So cube root of 27 is 3, and then you square it, you get 9. So that's your answer. T to the 10 over 9, a to the 8. Okay. Hopefully that was good for you. Moving on, question number 18. Ooh, probability. Now, probability. Now, as a choice with question 18, you can either do a tree diagram or you don't have to, because it's not necessarily a complicated one. You can do it without using a tree diagram, but I'm going to do the tree diagram method anyway, just to show you how it works. So 16 sweets in a bowl. At the end of the day, you're going to work out the probability of having 5 lemon sweets still in the bowl. So this question's about lemon sweets, isn't it? So the way I would break it up, if I was doing a tree diagram, was I have the probability of getting a lemon sweet and probability of not getting a lemon sweet. Okay. So how many lemon sweets are there altogether? There's 5. So obviously 5/16. How many are not lemon? Well, that's obviously 11/16. I mean, you can check that, but 4 blackcurrant and 7 orange. Okay. Yeah, 11. That's blackcurrant sweets. Come on. Yeah, so 11/16. Okay. Now you're not really interested in that. Okay, you're only interested in the result that you're not getting a lemon sweet. So you've got 3 people, Anna, Ravi and Sam. Let's not write down the first letters of their names. It could be awkward, doesn't it? So you've got Anna doing it, okay, and then you've got Sam doing it, okay, and then you've got, Ravi doing it and then Sam doing it, okay, so, stupid, why am I writing S for Sam? I just said I wasn't going to do that. So basically you want all 3 of them to not take a lemon sweet. So you don't need the rest of the tree diagram. Waste the time. Okay, you don't even need that. So when this person's got their sweet, remember the denominator is always going to decrease. So that could be 15, that's going to be 14, because there's 15 sweets left, there's 14 sweets left. And when there were 11 of these to begin with, after taking that, there's now going to be 10 of those, and after taking that, there's now going to be 9 of those. So it's as simple as that. Okay, so 11/16 multiplied by 10/15 multiplied by 9/14. So an easy question. You could have just written down that. Maybe somebody did. Great if you did, but I'm just showing you how the tree diagram would have worked for it. Okay, and you should get 33 over 112 as your simplified fraction. Okay, good. Question number 19. Ooh. Yeah, it's trigonometry, but with a 3D shape. This confuses people sometimes. This is actually an easy-ish question. Okay, so what you need to do is you need to locate the angle that you need. Okay, so just bear with me while I draw this out. So it says work out the side angle between AH. So that's H, and that's A over there. Okay, let's just draw these bits in. There we go. And so what I'm going to do is in a different colour, I'm going to draw in the line from A to H. Okay, there it is. Okay, and when you're going to work out the angle between that and the base, this is the plane EFGH, but that's just the base. When you work out the angle between that line and the base, you're going to look at the top of the line, and you've got to go straight down, that is vertically, down to the base. Okay, so you've got that, and then once you've got 2 sides of the triangle, join the 3rd one together like that. Okay, and that point there was point F. Sorry for mixing the colours up, but hopefully that is clear. So let me just draw that triangle out here to make it nice and clear for you. So that is a right angle triangle. Okay, and that's A, that's F, and that's H, and the angle we need is that angle there. I'll just put it in the diagram. I'm hoping that makes a lot of sense for you. Okay, so let's see what we've got. We've got this length here, okay, because it says that BG is 6, so that is 6, so that means that is 6 as well. So that is going to be 6 centimetres, of course. Okay, we need to work out either this or this. Which one is easier? Okay, I would suggest it's easier to work out FH. Okay, because you're told that the base of this is 9 and the width there, that's 5. Okay, so you can use Pythagoras Theorem for that. Hopefully you can see that. Okay, this is a right angle triangle, this is a right angle triangle, hypotenuse from a rectangle on the base. So let's just put some work in by here, shall we? So you've got FH squared equals 9 squared plus 5 squared. So FH squared equals 106. Okay. So FH will be root 106. So FH here is root 106. Use the exact value, root 106. Okay. And then we can use tan. Okay, because we've got the opposite and the adjacent. Tan theta equals 6 over root 106. Work out what that is, do the inverse tan of that, and you've got your angle. Okay, inverse tan of that is 30.2324, etc. So to 3 significant figures, that's 30.2 degrees. Okay, and that is it. Okay, I'm going to pause there because the next question's a real cracker. Question 20. How did you feel about this one? Okay, so this was the January paper, of course. So some year 12s, some of which were doing A-level maths as well, they had to go at the paper just because they hadn't got a GCSE, because they came from outside the GCSE system. Okay, they went through the paper. Okay, and I distinctly remember some of the year 12s who also did A-level maths. They were like, "How do you do this question?" So if the year 12 struggled a bit, I'm not surprised if some of you struggled. Okay, so here's the equation: y equals 4x minus 1 squared subtract a. This should really be the last question because it's the hardest in the paper. Okay, using the axes below, there, sketch the curve. On your sketch, show clearly in terms of a the coordinates of any points of intersection with the coordinate axes and the turning point. Now that's really a good clue as to how to do it. Okay, they're giving you a good clue as to how to do it. Okay, where this is the coordinates of any points of intersection. Okay, what it's asking you to do is consider what happens when x is 0 and when y equals 0. That's a really good starting point. Okay, so start there. All right. So when x is 0, what happens? You've got y equals negative 1 squared, which is 1, times by 4. So 4 subtract a. Okay. Now, where does that go on the y-axis? Is it here, here, here? Now, do you see in the question where it says a is greater than 4? What that means is just pick any number, 5, 10, doesn't matter what it is, just a number that's greater than 4, okay? So if you do choose, for example, a is 10, okay, 4 subtract 10, that's negative, isn't it? Okay, so what that means is that this y coordinate's be negative, so your y-intercept is somewhere down by there, okay? So that's going to be 0, 4 minus a. So that's 1 point plotted. Okay. Right, next, when y equals 0, we can work out x's. So what that means is this bit here is equal to 0. Okay, so you've got 4x minus 1 squared minus a equals 0. Okay, so you could just rewrite that as 4x minus 1 squared equals a. Okay, bring the 4 to the other side, so you've got equals a over 4. Square root both sides. So x minus 1 equals positive or negative root a over 2. Remember, you square at the top and bottom. Okay. Add on 1 to both sides. X equals 1 plus minus root a over 2. Okay. So bear in mind that a is greater than 4. Okay. You've got 1 plus a positive number. Okay. And you've got 1 subtract a positive number. So basically, let's just say a was, I don't know, pick a square number, 9, okay? So if a was 9, you'd have 3 over 2. And 1 minus 3 over 2, 1 minus 1.5 is negative, isn't it? So that means is you're going to have an x-intercept somewhere there and somewhere there, okay? I spaced them out because I know that 1 plus root a over 2 is going to be further away from the origin than 1 minus root a over 2, okay? So I'm going to label those 2 points. So that's going to be 1 plus root a over 2, 0. And this one here is going to be 1 minus root a over 2, 0. Okay? So that's the x-axis crossing points. Okay? You can now draw the curve in, because you know this is a parabola. Yeah? And what you also know is that parabolas are symmetrical. Okay? And because it crosses here and here, the minimum point is going to be halfway between here and here. So somewhere there. Okay? So let's just draw this in as nice as I can. There we go. So there's our minimum point, and then we go up again, and like that. Okay. It just needs that minimum point there finding. Yeah, it's kind of. How does that look? Yeah, it looks alright. Okay. We just need to find that minimum point. Okay. So for that, we use this bit here where we've completed the square. So let's just use a different colour. Okay. So you've got the 4x minus 1 squared minus a. Now, when you complete the square, the bracket bit tells you what the minimum value is going to be because you want that to be its smallest. Okay. I didn't say that very well, so I'm going to say it again. All right. So the minimum value, okay, is what's the lowest possible value of y. Okay, because remember it's y equals. So the lowest possible value of y. That's going to happen when this is at its lowest value. When this is its lowest value, something squared, you know, the lowest square number is 0. Okay, not 1, 0. 0 squared is 0. It's smaller than 1, isn't it? Okay. So when x is 1, that is going to be its smallest value. Okay. And when x is 1, y is going to be 4 times 0, subtract a, negative a. So that's it. So the coordinate 1, negative a. Okay. Or you could have deduced that the midpoint between that and that. Remember, that was question 1, wasn't it? You add the x coordinates together. Well, when you do that plus that, divide by 2, you get 1. Okay. And the minimum point there is just sort of negative a. So that's the question. It wasn't really difficult. And not the year 12s were thinking about, but yeah, there you go. That's question 20. I'm going to stop there because that was a nice enough question to have as a standalone video, wasn't it? Oh, by the way, there's a lot more of this in year 12 and year 13. Yeah, so try and enjoy graph sketching. Okay, this is a nice question, wasn't it? Question 21. You'll see this again in year 13, those who do A-level maths, okay? So you need to find f of g of x. Now, do you remember this? What you've got to do is just look at g of x first, and then you do f of that, okay? So what was g of x? G of x was x plus 3, wasn't it? So at the moment, if I cover that up, that's correct. G of x is x plus 3. When you do f of it, what it means is you've got to substitute that in to the function f, okay? The function f is x squared minus 2x. Now what that means is you've got to replace x with x plus 3. So instead of x squared, you'll have x plus 3 squared. Instead of 2x, you have 2x plus 3. Does that make sense? Okay, because the function f means you're going to put something in, square it, and subtract 2 times your input. Okay, if your input is x plus 3, then you've got to square that and subtract 2 times x plus 3. Okay, what you've got to do is you've got to simplify that first of all. Okay, so let's expand the brackets there. Hopefully you can do it simply. X squared plus 6x plus 9. And then subtract 2x, subtract 6, and that's going to be x squared plus 4x plus 3. Okay? And then it says you've got to work out the inverse function. So I'm just going to call that h of x for a moment. Do you remember what to do to find the inverse? The first thing you do is write it as y equals x squared plus 4x plus 3. And then you've got to make x the subject. You've got to make x the subject of that, which is quite difficult if you've not seen the technique or if you're out of practice with the technique. You've got to get x on its own. The only way of doing that is to complete the square. You've got to complete the square on this question. Okay, so complete the square, you get x plus 2 squared, subtract 1. Now if you're not comfortable with that, practice, because you've got to do that very quickly in year 12 as well. All right. There's a lot of stuff at the end of this paper where you just need to be able to do this very quickly in year 12, okay? Otherwise it's a bit difficult. Okay? So the reason that works is because when you expand these brackets, you get x squared plus 4x plus 4, the subtract 1 gives you x squared plus 4x plus 3. Okay? Right, you've got to make x a subject, so I'm going to put the 1 to the other side, so we'll get y plus 1 equals x plus 2 squared. I'm going to square root both sides. How many of you put plus minus? Yeah, plus minus, square root y plus 1 equals x plus 2. And then I'm going to put x equals, and put the negative 2 onto the other side, so negative 2 plus minus root y plus 1. And I've just written it like that. Okay. Now, if you haven't put plus minus, if you just put plus, you get away with it. Okay. Why do you get away with it? This is explained in a lot more detail in year 13. Okay, this is explained in a lot more detail in year 13. But at the top of the question somewhere, it says this. Okay, it says x is greater than or equal to -2. They didn't just put that in for the sake of it. They put it in to tell you that it can't be plus minus, it's one or the other. Okay, because look, here's x. Okay, if you have -2, subtract that, it's no longer a number that's greater than or equal to -2, is it? Because root y plus 1, that's never going to be negative because it's square root of something. Okay, so you can do -2, subtract this. Okay, that won't work. So it's got to be, okay, that there. Okay, just be careful of that. Okay, because if the question said x is less than or equal to -2, then you'd have had to have had that. That happened with a year 13 question a few weeks ago, and it caught about 90% of them out. Okay, so you just bear that in mind. All right, and then what you do is just swap the x's and the y's over. So you put y equals -2 plus root x plus 1. Okay, and that's what you write in your answer spot. Okay, I'm hoping that that was helpful to you. Final question, question 22. Okay, right, here it is. Okay, if you've not drawn a sketch, what are you thinking of? You can't do this question without drawing a sketch. Okay, so just draw in an isosceles triangle. It does not have to be accurate. Okay, you don't have to get the coordinate positions correct. Okay, so look how I've drawn it. I've basically drawn it as if JK is horizontal. It's not, but it's just a sketch. Okay, so put in the points H, J, K, the coordinates that you're given. Okay, and it does tell you that the gradient of HM is 2. All right, so I've written that down. It tells you that the length JK is root 80. So that's all the information in the question on a handy diagram. Okay. Now, isosceles triangles. Okay, when you join the top of the isosceles triangle to the midpoint of the base, it splits it into 2 equal right-angle triangles. You need to know that fact. Okay, what's the importance of that? Okay, this is about gradients. If they tell you the gradient of HM is 2, then the gradient of JK is -1/2. Okay. Now, why is that? It's the rule with perpendicular lines, isn't it? Okay. When you've got 2 perpendicular lines, the product of their gradients is -1. Or if the gradient of one number is m, the gradient of the other is -1/m. So you do the reciprocal of that and make it negative. So the gradient of JK is -1/2. That's your starting point. Okay. Use those coordinate values to set up a relationship between J and K. You're not going to solve it in this bit. You're not going to be able to work out J or K, but it gives you a relationship. Okay. Because that's something else this question is about. That's simultaneous equations. That's what makes it hard. Simultaneous equations, you know, usually make a question quite difficult. Okay, because most people, it doesn't look like a simultaneous equations question, does it? But it is. Okay, so let's just do that. Okay, so gradient of JK. So that's going to be, how do I want to do this? Okay. So K minus 15. So that's the difference in y coordinates over 6 minus J. Make sure you're consistent. So I've done that, subtract that, and that, subtract that. Okay, make sure you get the right way round as well. Okay, and that's equal to -1/2. Okay, and let's just simplify that because it's a good idea. So if I put the 6 minus J onto that side, we have K minus 15 equals -1/2 6 minus J. I'm going to divide by half, which is multiplying by 2. So if I times by 2, I get 2k minus 30 equals, the negative is still there. Okay, so -6 and then plus j. Okay, and then it's easier to make j the subject. Can you see that? So if I write j as 2k minus 24, what I'm saying is it's better to make j the subject than k the subject. This is a simultaneous equations question, and so in this case it's probably a good idea to just make one of them the subject and substitute the other one in. Now, how do you get the other one? How do you get the other relationship? Okay, it's by using this. You know, they've not given you that just for, you know, the sake of saying here's a nice number. Okay, you've got to use it. Okay, so the length from J to K is root 80. So you've got to work out the length, the distance between 2 points. Do you remember how to do that? Okay. So just as a brief recap. Okay, so you've got 2 coordinate points here and here. Okay, so just join them together, straight line like that, and then just create a right angle triangle. Okay, and you're after difference in x coordinates and difference in y coordinates. Okay, so if that is coordinate x1, y1, and that is coordinate x2, y2, okay? And then this bit here will be the difference in x coordinates, which is x2 subtract x1. That bit is difference in y coordinates, which is y2 subtract y1, okay? And that's a right angle triangle, okay? And then what you want to do is you want to do that squared plus that squared equals that squared. Now in this case we're saying that that is root 80, okay? I'm just going to leave that by there, okay? So the difference in y coordinates, so I'm going to do k minus 15, okay? So k subtract 15, and then squared, so that's effectively that bit there, you see. And then added to difference in x coordinates, because just squaring them doesn't matter which way around you do it, okay? So you could do 6 minus j or j minus 6. I'm going to do j minus 6. Okay, check. If you do 6 minus j, you get the same answer as j minus 6 squared, okay? So you've got that squared plus that squared equals that squared. Root 80 squared is just 80. So you've got that, okay? What are you going to do with that? Well, what you're going to do is you're going to put j equals 2k minus 24 into that. All right? So you're going to have k minus 15 squared plus, and instead of j, you're going to write that, which is 2k minus 24 minus 6, so minus 30 squared equals 80. That's just one equation now that you've got to solve, and you've got to work out the value of k. And get rid of this now, I think. So let's expand the brackets. So k squared minus 30k plus 225 plus, expand these brackets, 4k squared minus 60, so that's minus 120k plus 900 equals 80. I hope I didn't go too fast here. Okay. And then you've got that plus that is 5k squared, and that is subtract 150k, and then you've got that plus that is, that's 1125, okay, and then I will subtract 80, okay, so 1125 subtract 80, that's equal to 1000 and what is that, 45, so plus 1045 equals 0. Yeah, let's just rub that bit off. Okay, let's divide everything by 5. Okay, so k squared minus 30k plus 209 equals 0. Can you factorise that? Yeah, you can. Okay. How will it factorise? So look, you'll have k subtract something, k subtract something else, because there's a negative there and that's positive, so it must be k minus and k minus. The only easy thing about this is that you've got k squared rather than 2 or 3 or something else, k squared. Okay. You want two numbers that add to make negative 30 but multiply to get 209. Just play around a bit, okay? So I mean, it's got to end in 9 when you multiply them together. Okay, so two numbers that add to make 30. Okay, you can keep them going for a long while, but 11 and 19 are the ones to try really, because 11 and 19 obviously add to make 30, and the 1 times 9 at the end makes that. So I'm going to try that and see what happens. 11 and 19. Now 11 times 19, that's 190 plus 19, that's 209, that's good. And that, yeah, it works out. So k equals 11 or 19. Okay. We've also got to work out what the corresponding values of j are, so let's just remember that. Okay, so when k equals 11, j, why have I written it all the way over there? Sorry. When k equals 11, I'll tell you what, I'm going to write it like this. When k equals 11, j is going to be equal to 2 times 11, 22, subtract 24, negative 2. And when k is 19, you have 2 times 19, which is 38, subtract 24. 38 subtract 24 is 14. Okay, just read the question again. Right, it says find the value of j, not values. That's the difference. Okay, so what that means is only one of these answers is correct. So somewhere in the question it's going to tell us which one to take. Can you see the bit where it says j is less than 0? Okay, it's about the third line down. J is less than 0. So that means that's the one you want, because J is less than 0. So in your answer space, you write down K is 11 and J is negative 2. Okay. That is the sort of question you expect to see a lot of in year 12. Okay, so it's about coordinate geometry. Okay, you could have a triangle, an isosceles triangle on a coordinate plane like you've got here, and just work out this. So there's a lot of GCSE Maths, isn't there? Okay, but you know that makes a nice A-level problem. Okay, so if you didn't quite understand that, replay the video again and again and again. Because if you're doing maths next year, it's important you can understand an example like that. Okay, that was the whole paper. Okay, hope that was helpful to you.